All right, now we're going to move to how do you plan when teaching word problems? Well, first you got to make sure you plan for your graphic organizer. You have to plan for your task analysis, the one you're going to use to solve the problem. I don't think it surprises anyone to find out that you have to plan explicit and systematic instruction for teaching word problems. And then finally, you have to plan for generalization. You have to provide opportunities for students to demonstrate, perform these skills across multiple contexts. So you might have them use different types of manipulatives. You might teach that, work with them on it, and then you might have your paraprofessional work with them on it. You might have them use these strategies or solve word problems in real world situations in your classroom. So again, you have to plan for generalization. So, the first step that you're going to do is again, you're going to plan for your graphic organizer or any other type of visual supports that you may need. For example, if you look at the change graphic organizer, when you are doing a change subtraction problem, it has a little trash can at the bottom. So in the graphic organizer, there are embedded visuals because students understand like throwing something away and it being gone, which can help them understand, again, subtraction. So you want to make sure that whatever graphic organizer you're using visually represents the type of problem that you're teaching or the student is solving, and that it demonstrates the relationship between the different quantities. You want to make sure that it will help the student organize the information from the problem. So that is why it's so important to understand the structure of the word problem so you know what type of graphic organizer you would use. It's also important that you align the space on the graphic organizer with the size of the manipulatives that you're going to be using, because you'll notice that on the group graphic organizer, those small group circles are pretty small. So you have to make sure that your manipulatives align with that, okay? And that might mean that you have to adjust the size of the manipulatives, or you might have to adjust the size of that portion of a graphic organizer. Color coding can help. So that might be some type of a visual support. And we'll see an example of that in just a minute. And there's color coding in the graphic organizers. And again, there might be other types of visual supports that your student would find helpful, such as the picture of the trash can. So again, here are the graphic organizers from the Solutions Project. And you can see that color coordination and that organization of information in each of those. We are going to be working with practicing each of these types of word problems in class. And so here is a graphic organizer that, or excuse me, a graphic that you might find beneficial. It'd be something that I would take a screenshot of because it will help me down the road. Again, we're going to work on that in class. You're also going to plan for your task analysis of how you're going to solve the problem. So you want to make sure that before you do this with students that you practice, that you walk through the problem using the task analysis, and that you write down each step that you take to solve it. And that can mean that you actually demonstrate that, but it also might mean that you check off each of those steps as you go through, because you want to make sure that you're doing them in the right order. And if you do that when you're working with a student, you're also teaching that self-monitoring as well. Here is some of the color coding that I was talking about. If you look at that top one, each of those squares is color coded to coordinate with the group graphic organizer. So there's a small group that's green, there's a small group that's red, and then the big group is blue. And then there's also one, these are on because it's going to ask you to fill in a number sentence. I wanted to let you know that these are on Canvas under our resources. So I talked about planning for explicit and systematic instruction. And again, that did not surprise anybody, I'm sure. But when you're doing that, one of the things that I suggest, and that's very beneficial and that Project Solutions suggests, is using model lead tests with an embedded system of least prompts in the lead. So you would model, you would do I do, then you would lead or do we do. And when you're doing we do, that is your guided practice, you are going to embed a system of least prompts, and that is your scaffolding. And then you're going to test or you do. So let's see what that looks like. So first you're going to model do I as I do, and you might say, first watch me. And then you're going to model solving a problem, a word problem, following the task analysis and using that graphic organizer and doing a think aloud as you go. Then the next thing you want to make sure you do is that if needed, and it's likely to be needed in those initial stages of teaching and learning, is you want to make sure that if needed, you model several problems because students are not going to get it the first time around. It's a complex skill, right? And it's likely the first time students have ever engaged in a skill like this or with a skill like this. Next, you're going to do we do as you lead, and that might look like let's do it. Now, let's do it together. Now, listen to this part. You try first. If you don't know what to do, ask and I will help you. Does that sound familiar? Well, we want to make sure that we're doing that during we do because we're using the system of least prompts. And when you use the system of least prompts, what do you always do first? You give that student the opportunity to respond independently before you provide any kind of support through prompts. So you're going to say, you try first. If you don't know what to do, ask and I will help you. And that is because we want that errorless learning. And then you would move through a prompting hierarchy. And I'll give you an example of one in just a second. After that, you're going to move to you do or the test, and you're going to say something like, it's your turn to show me what you know. And then you're going to assess their knowledge by not prompting them. I'm not going to prompt you, and I'm going to collect data to see what you can do independently, what kind of correct responses you demonstrate for each of the steps in the task analysis. Now, if they make a mistake or make an error or they don't respond, you want to jump right in with the system of least prompts. And if you notice that they're not getting it, then you may want to go through and do a review afterwards. So we talked about what explicit instruction would look like. Now let's look a little more closely at the systematic instruction and what that looks like when it's embedded in the we do or the lead section of explicit instruction. So just as a reminder, you're always going to start with your attentional cue and that task direction. And then this is an example of the prompting hierarchy, and this is what I would encourage you to use, is you're going to first start with a non-verbal prompt, a non-specific prompt and a gesture. So let me say that again. You're going to start with a non-specific verbal prompt and you're going to pair it with a gesture. And what that might look like is you pointing to the step in the task analysis and reading it aloud, reading what it says. So in this case, it might be circle the whats. That's my non-specific because I'm just reading it. And the gesture is pointing to that step in the task analysis. If the student gets it correct, or I should have said first, obviously, you give them opportunity to respond correctly. If after I give that non-specific verbal prompt paired with the gesture, they get it correct, I'm going to provide reinforcement. If they make an error or no response, I'm going to move to a specific verbal prompt. And that might look like reading it again and providing additional information that's going to help lead that student to a correct response. And so that might look like circle the whats. Remember, that's what we're talking about in our word problem. Or that's the thing we're talking about in our word problem. And so they may circle cookies, for example. They're gonna know then that we're gonna look at cookies because that's what. That's our circling the what. If they make an error or they don't respond, then you're going to move to a model and you are going to actually model what that step is. Obviously, after you model, we want to know if they can get it correct on their own, so you're always going to go back and do a retest on them. We're going to do some demonstrations. I'm going to do some demonstrations with the limitations I have of doing them here digitally, but then in class I will also do demonstrations if you would like, and I can get you all are going to work in small groups, and so I can come into your groups and demonstrate if needed. As a reminder, again, these graphic organizers are under our resources on Canvas, but what I really want to show you is that this is a way that you can teach, and you want to fade these out over time, is at first I'm going to provide you with the color-coded number sentence. Once you are proficient using that, you're demonstrating proficiency, then I'm going to fade it to the solid color number sentence graphic organizer. And then once you're able to do that, I'm going to fade it to independence, and you're just going to write those numbers out and write the equation as a whole. So again, we want to make sure that we provide those supports as needed and we fade them as quickly as we can. All right, so now let's go through an example of what this would look like if you were actually teaching this to students, all right? So the first thing we're going to do is we're going to look at our task analysis, and then the step number one on our task analysis, let me move this down so you can see. Step number one on our task analysis is to read the problem. I can't see the problem, so I might get the first sentence wrong because it's covered up by a bar. But Rowan's class is taking a poll on class pets. So they're taking a poll on class pets. Rowan has 3 cats. He has 2 dogs. How many pets does he have altogether? I just completed step 1. Check. Step 2, circle the whats. When I look for my whats, I see cats and I see dogs. The next thing I need to do, check, is I need to find the label in the question. So when I look at my question, I find pets, and that is my label. Next, I need to determine, are my things the same? Are my whats the same, or are they different? And because I have cats and dogs, and they're circled and easy for me to see, I can tell that they are different. The next thing I'm going to do is I'm going to use my rule. Well, I know because they're different and I'm combining them that I'm going to be doing a group word problem. And my rule is small group, big group. Cats, dogs, pets. All right, now I need to choose my graphic organizer. Here is my group graphic organizer. After that, I need to circle my numbers, and I could be checking all of this off as I go so that I'm demonstrating that self-monitoring. I'm going to circle my numbers. My numbers are 3 and 2. Next, I'm going to take those numbers and I am going to fill in my number sentence. There we go. I have filled in my number sentence, but only with the numbers at this point. Step number 9, and again, checking these off, is I need to decide, am I doing addition or am I doing subtraction? Well, I know because it's a group word problem that I am going to be doing addition. So then I would add my addition sign here. After that, I'm going to move to step 10, which is making my sets. I'm going to put 3 cats in my first set. 1, 2, 3. I'm going to put 2 dogs in my second set. 1, 2. And then after that, I'm going to combine my sets to solve my word problem. 1, 2, 3, 4, 5. Now that I have solved my word problem, I'm going to write my number in my number sentence, and then I'm going to add my label. And so that is a demonstration of how you would teach a group word problem using our task analysis. All right. Oh, let me see. Well, that one got circled. That one did not appear, so we're going to pretend like that one's not there. All right, so now let's take a look at a compare word problem. All right, so let's look at this one. Sydney and Cooper work at the car wash. Sydney washes 7 cars. Cooper washes 3 cars. How many fewer cars did Cooper wash than Sydney? So that was the first step, was to read the word problem. So I could check off step 1. Next, I'm going to circle the whats. When I circle my whats, I'm going to circle cars and cars. Oh, those are the same. Those are the same, right? Now I need to find my label. My label is cars. Now I need to determine, is it the same? Is it different? Or is it fewer? Well, this is why I need to look at everything. I need to look at my structure and I need to look at my words or my phrasing. Because if I look right here, I can see how many fewer. And that compare phrase lets me know that I am doing more or fewer, and specifically fewer in this case. Next, for step 5, I'm going to do my rule. Bigger number, smaller number, the difference between the two. 7 cars, 3 cars, subtract the difference between the two. All right, next I'm going to choose my graphic organizer. I've done that. I'm going to move to circling my numbers. I circle my 7, I circle my 3. I'm going to move to step 8. I fill in my number sentence. After I finish my number sentence, filling in the numbers in my number sentence, now I need to determine, am I doing addition or subtraction? Well, I can tell 2 reasons that I am doing subtraction. One that helps me know is that they're the same, but I can't depend on that on its own. I also see my compare phrase, which is how many fewer. So that lets me know I'm doing subtraction. I'm going to put my minus sign in. Now I'm going to make my sets. Cars, 1, 2, 3, 4, 5, 6, 7. Now I need to do Cooper's cars. 1, 2, 3. Now that I've made my sets, I need to look at the difference in between. So I'm going to pair them up. 1 and 1, 2 and 2, 3 and 3. I'm going to move everything that's left down into my difference circle because I subtracted, and then I'm going to count how many I have left. 1, 2, 3, 4. I'm going to write my 4 here in my equation, my number sentence, and add cars. And so how many fewer cars did Cooper wash than Sydney? He washed 4 fewer cars. So that is an example. And now what I want you to do is I want you to try these yourself. Now that I've shown you how to do them, I want you to try it yourself, okay? So try this one now. Stop the video and come back. And for this question, I want you to tell me how you did on this one, how you did implementing it on your own. All right, let's look at another one. On this one, we're going to start by, you know what I want you to do actually? Before I even go over this, I want you to stop and I want you to do it by yourself. Don't watch the video yet. Do not watch the video, although there is a hint right here. Don't watch the video yet. Try it on your own and then come back and I'll go through it and you see if what you did aligns with what I do, okay? All right, I'll see you in just a minute. All right, now that you've tried it, let's do it together. The first thing we're going to do is that we are going to read the problem. I wish I could get rid of that bar. Elrod was making cookies for a school party. He had 10 cookies to pack, so he had 10 in total. 3 cookies broke, so he could not take them. How many cookies are left for Elrod to take to school? So I just read my problem. Now I'm going to circle my whats. I have cookies and I have cookies. Those are my whats. Next, I'm going to look for my label. My label, again, is cookies. Now I need to determine, are they the same or are they different or are they asking for fewer, more or fewer? Well, I don't see a compare phrase, so when I look at it, I know that they're the same. They're the same. So I went ahead and circled the same. Now I'm going to do my my procedural rule. So my procedural rule is one thing, same, and because he broke cookies, I'm going to take away, subtract, change. And so that might look like cookies, one thing, 1 thing, same, or 10 cookies, same, 3 cookies broke, take away, change. All right, so let me do that one more time. I'm going to do the 10 cookies. 10 cookies, same, 3 cookies broke, take away, change. So now I've done my rule. I choose my graphic organizer. I'm going to circle my numbers. And then after I circle my numbers, I'm going to fill in my numbers. I know that I'm doing subtraction because some of them broke. And then I know that it asked how many got left. So while I'm not using my keyword, I can use that to support me. And then I'm going to make my sets, okay? So in this case, I would put 10 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 3 of them broke, so I would throw them away, take away, and that would subtract, move them over, and that is my change. So again, that would look like 10 cookies, 3 broke, take away, change. And then I would write my answer and my label here, which would be 7 cookies. All right, I want you to try that. I want you just to walk through it on your own. And if you actually use the PowerPoint, you can click through it like I did. And you can say, but Ty, you just did that. Why are you making me do it again? Well, I want you to practice it. I want you to practice it and see what it's like because initially it's not easy. You're not very fluid at doing it until you do it a couple of times. And I think you've even seen that with me. Haven't really practiced this since last semester, so I had to sit down and do it a couple of times, even though I have used this many times myself. All right, quick evaluation. How are you feeling about things? If you have any questions, make sure that if at the end of class or the end of this session your questions are not answered, that you reach out and let me know, or that you include it in a document somewhere, email them to me. All right, I will see you in the next video.